Hello, everyone. Thank you so much for joining us right now. Anand and I will be talking to you about the future of AI and how we believe that this future is fundamentally will be confidential. I'm Nelly Porter. I'm Director of Program Product Management in Google GCP, owning the whole entire encryption and confidential computing space here in Google. And Anand.
Hey, Nelly, a virtual high five to you from Portland, Oregon. My name is Anand Pashupathy. I'm a VP and GM at Intel in our product assurance and security organization. And I'm responsible for making confidential computing real on Intel platforms now and into the future. And Nelly, I'm so excited about this important topic that you and I are going to talk about. Let's get the show on the road.
Thank you so much, Anand. And you are and your teams are great partners in this journey for all of us. Thank you for being there. So let's start. And before we will talk about what we do in this area and why AI is changing the whole entire world, let me start with customers. And when we're talking about AI, the first and foremost important part for us, what is the customers want to have when they bring their AI, Gen AI workloads to cloud. And because I'm a cloud product person, I will start from this point. So we see three types of customers. Model producers, those customers that are actually creating these foundational models that all of us benefit from. Model tuners, people that take in those models and tune it for their specific use cases. And model consumers, everybody else that building multiple agents and agent-like capability on CSPs on cloud. And all of them need different things for their use cases. But one thing is continue to be consistent across all of those different customers. They need to protect models, they need to protect data, and they need to have cryptographic confidentiality from cloud provider. And it's where confidential computing, I guess, is going to help us to address all of those use cases. Choosing the privacy is very difficult and very tricky. And the reason why, because when you're talking about AI and it's enormous amount of data that required not only for training, fine-tuning, but also doing inference, utilizing the model. It's very critical for customers from financial, healthcare, or government sectors, especially as they regulated and has a lot of policy-related challenges to bring the workloads and their AI, Gen AI specific workloads to GCP. The risks that they foresee for their data and models are not different from anything that they do and when they bring their general workloads to cloud providers. And again, for AI, there is even more complexity involved. They need to ensure that the model and data doesn't have any compromises related to confidentiality and privacy. Data leakage and other threats are very important in focus for them. We have customers that also worried about model theft. As you remember, those customers are doing model creation or model tuning. For them, this model becoming their own IP and they have to protect it. And there is plenty of complexity, especially in regulation space with export control compliance and regulation policies that our customers across the world have to comply. And with AI-specific capability, it's becoming even more challenging. Confidential computing as a technology, as a tool, unlocks very many new ML AI use cases, especially when the secure collaboration or joint ML data is required. And because, again, as higher fidelity data is used for multiple processes to train, fine-tune, or even inference in context learning for customers, we have to provide for them ability to do it safely with privacy first. Proprietary IP model protection, confidential computing as a tool can help to create these particular enclaves, capabilities that allow customers to do what they need. And multiple other use cases that you familiar. One additional interesting topic that I want to bring to this conversation is how this particular technology, confidential computing, can help us to address policy and regulation requirements that our customers facing. So there is plenty of complexity on data sharing, especially when you are located in different regions, so your users and customers are located in data regions, what to deal and how to deal with law enforcement access. Cross-border data sharing and transfer is also complicated. There is a report that was published very recently with Future of Privacy Forum that advising, utilizing, and looking into confidential computing as a proper factor to address some of those concerns. And I'm really glad that, again, our customers and our policymakers understand and appreciate the value it can provide. But to build it, we need foundation. And this foundation is offered by companies like Intel, AMD, ARM, and NVIDIA. And with me, Anand, to describe to you and explain to you what Intel is doing to help with confidential AI capability, in particular in Google Cloud. Anand.
Great. Thank you, Nelly. As Nelly said, super proud of our collaboration between our two companies. And there are really three basic components that I call building blocks for confidential AI in Google Cloud. Let me start with Intel AMX technology, which is advanced matrix acceleration technology. And the intent of Intel AMX is to help with matrix calculations, which are really foundational to AI. Instead of linear algebra, think about two different matrices being calculated or being multiplied in one single cycle. And that really gives you superior performance at the end of the day. Intel TDX or trust domain extensions, it's the basis for hardware-enhanced VM isolation. And this is technology that Intel brought into Google Cloud last year. And on top of this, one of the significant components of confidential computing or confidential AI is attestation. And Intel has Intel Tiber Trust Authority, which is really a service which gives you uniform, consistent attestation information across your entire fleet from edge to cloud. Now, if you move to the next slide, Nelly, this slide really talks to you about the performance of confidential AI. And let me describe this slide to you. So the data that Intel and Google collaborated on was really to study confidential AI performance, because there was a lot of talk about, hey, AI performance gets impacted by confidentiality, etc. We wanted to go test that out. So when you look at this chart, let me describe it to you. The blue bar indicates Xeon 3 platform performance. The red bar in the middle shows you Xeon Scalable 4 performance with AMX turned on. So when you look at these two bars, it shows you a gen over gen comparison between Xeon 3 and Xeon 4 Scalable. The orange bar shows you confidentiality turned on, and it really compares Xeon 3 without AMX and TDX with Xeon 4 with AMX and TDX. And when you look at the workload that was ran through this, it was a Llama LLM with 7 billion parameters and 13 billion parameters. And when you look at the time per output token, there's a 2.7 to 2.9x improvement between Xeon 3 and Xeon 4. And you see a throughput improvement of almost 7x between Xeon 3 and Xeon 4 with TDX and with AMX. So hopefully this puts to rest the concern that confidentiality, while reducing some percentage points in performance, but when used with AMX, significantly improves the performance of your workload running in confidential AI on a Google cluster, which is incredible news for us. Now, I told you very briefly about attestation being a critical component of confidential computing. I'm going to double click on Intel Tiber Trust Authority. And at the end of the day, there are several ways in which you can do attestation on Google Cloud. But like I said, I'm going to double click underneath this. And one of the biggest advantages of Tiber Trust Authority or Intel Tiber Trust Authority is the ability to unify information across your entire fleet into a set of consistent deliverables and consistent view that is delivered to a customer, whether you're deploying in the cloud, on the edge, or on-prem. The other thing that this really provides you, the attestation is independent of the infrastructure provider. So it is built on zero trust principle because you're not depending on the infrastructure provider also providing you attestation. And lastly, we work with NVIDIA in order to give you one singular attestation as the workload traverses from the head node, the CPU being the head node, and the GPU, so that you don't get two independent attestation signals coming back. You get one in the same pane of glass with consistent UI and consistent solution from Intel. So, which is again, great to get that independent attestation in a hybrid or in a cloud environment. So with that, I think, Nelly, I'm going to hand it back to you.
Thank you so much, Anand. And to emphasize the point that you made, confidential computing is providing multiple things to our customers, especially when AI, ML involved. And we're talking about confidentiality of the workload, but also verifiability of this workload. And attestation and multiple options of attestation is very critical for the whole foundational values that confidential computing provide. And as you said, ability for us to uniformly attest across multiple CPU, GPU vendors, and being able to consume this capability with third-party attester as Intel offering is very important value add to all what we can do in Google Cloud. And it's again, as we looking into confidential cloud platform, exactly as we started, confidential confidential infrastructure, its capabilities that we offer on CPU and GPU, looking at, again, this end-to-end, and we're talking about different ways that customers can deploy the workloads being on GCP through confidential GCP services or utilizing confidential applications like confidential space for secure collaboration or MPC use cases, or what we call confidential AI, from confidential GCP services, especially for AI ML workloads. What we hear, our customers need to do a lot of work on their data sets. And when they need to utilize what we call data prog and data flow capability to have the Hadoop, Spark, or MapReduce functionalities that they absolutely relying to clarify, to simplify the data sets that they will use for training, fine-tuning, and also for RAGing the workloads. Saying all of that, I want to kind of zoom out of specific implementation of confidential computing on GCP and talk a little bit about what is the end-to-end story for our customers. They're not only looking for making confidential for compute or accelerators, but they're looking for end-to-end story to protect their workloads, their data, their models when they bring it to GCP, to cloud provider, when they store it in GCP hands, and when they actually use it utilizing compute, storage, networking, and accelerators to accomplish that. And to be able to provide confidentiality end-to-end, we always think about this as a system. So what this system has in common? We're utilizing encryption end-to-end to provide confidentiality of the data models, workloads for all customers. And encryption, you can't talk about encryption today, Anand, without talking about quantum. So quantum is definitely offering significant value for multiple areas. Again, we're talking about threat detection, understanding the patterns much faster, much better, and also in cryptography, thanks to the whole scare of quantum day, a lot of cryptography work started to show up, and we are so, again, interested in that. Google spent many, many years contributing to quantum and post-quantum cryptography as well, and I absolutely would like to hear your feedback on this. But before we will start, I want to introduce to you Willow. And Willow is the quantum computer, quantum systems that Google announced in October last year. And Willow is incredibly interesting new breakthrough capabilities that also used for some quantum AI family and solution as well in Google. The cool thing about Willow, it can do a lot of work very fast. And that's why this quantum computing becoming so interesting area to all of us, to all industry to watch and get excited about. So one of the tasks that Willow produced, and it was very well advertised, they've done it compared to classical computers, the most advanced classical computers. It would take those classical computers literally 10 in the power of 25 years to complete this task. When Willow was able to do it in 5 minutes. One of the biggest things that Willow address is ability for us to have much better error correction technique and also much more stable qubits that Willow is built on. So all of this capability and all of these advances are bringing very important topic for us to discuss. What do we do as we build confidentiality of the entire system based on encryption? So why encryption is important, you understand it. But why post-quantum cryptography is so critical, and we need to start reminding all our partners, industry, customers to start taking it so seriously. And the reason why, because all crypto migration takes enormous amount of time. So the ECC algos that you're probably very familiar with took 2 decades to gain some adoption. AES, it took a decade. So post-quantum cryptography algorithms, to get some traction, to get some adoption, it will take significant time. But we don't have too much time. We don't have, again, luxury to expect that it will happen in very, very long time. So what we will do to protect ourselves, our system, our world from quantum, utilizing quantum. So first and foremost, we need to think about what is a quantum attacks and what is a threat model around that. So not all cryptography will be in trouble. Good news. However, asymmetric cryptography and asymmetric encryption for communication, for encryption on the wire, and also digital signing is one of the biggest and most important thing we need to bring our customers, our partners, the whole industry attention to. Symmetric cryptography to encrypt the bulk of the data with symmetric keys, no big trouble because every single cloud provider support high sizes keys for this encryption and these things will be in order. And fancy cryptography, the whole different, again, maybe not as well-known cryptographic algorithms, I don't think it's a huge problem right now. So please think about what we as industry can help our customers to start prioritizing, start thinking about asymmetric encryption use cases and digital signing. So why digital signing is important? So, and why do we care about this? It's not this kind of attack that everybody already agrees, store now and do something later when quantum computers will become reality. But digital signatures are fundamental to establish authenticity and ensure that, again, the all things that we trust, especially with the long lifetime, will continue to be trustworthy and not forged. And that's why we absolutely need to continue to invest in this area and help our customers and our partners to take advantage of what we've done. I want to emphasize the importance of post-quantum digital signatures, not only something that everybody well aware how we will protect our encryption on the wire, and why digital signatures are maybe not the fancy things, but very important, very long-lived cryptography. Everything that we trust is relying on digital signatures. Make them post-quantum safe is critical. Anand, what Intel is doing for post-quantum vault and how Intel helping us with post-quantum cryptography?
Absolutely, Nelly. Thank you. Post-quantum is a topic that Intel has been researching for a long time. And I completely agree with you in terms of your priorities of how we should be dealing with post-quantum cryptography and how do we protect our assets in the future. Some of those examples you already gave. Intel has a two-pronged strategy to dealing with quantum computing or post-quantum computing. The first one is to protect our own platforms, right? So that's job zero for us. It's something that we're really focused on. And the second thing is to provide hardware acceleration to some of the new upcoming post-quantum crypto algorithms, right? Let me talk to you about what we are doing to protect our own platforms. To start with, in Xeon 6, we actually have moving to PQC compliant technologies where it's the first CPU to use PQC microcode signing technologies or algorithms like XMSS and LMS. And we also improved our encryption algorithms for Intel SGX and TDX memory encryption to AES 256. Now, when it comes to acceleration in a post-quantum world, given that some of this is going to be pretty compute intensive, any support that the hardware can provide is just extra bonus. And for AES 256, that acceleration is already available to you today in the form of AES NI instruction set. So that gives you that acceleration that you need in hardware. And for some of the new algorithms like MLChem, which was called Kyber, and MLDSA, which was called dilithium, and SHA-3 algorithms, those support for the acceleration for those algorithms will come in future Intel platforms. So this is a very interesting topic, and I really look forward to how our community comes together when we start marrying PQC with confidential computing and protecting our assets in the future. Back to you, Nelly.
Thank you so much, Anand. And you touching very important point. I'm absolutely agreeing with you that confidential computing and other encryption technology of protecting data at rest or data on the wire communication channels, it's all have to take advantage of PQC crypto. But as you said, it's not very easy task because in the past, every single new cryptographic algorithm provide performance improvements, scalability improvements, and it was very good advantage for compared to whatever we had in the past. Unfortunately, with post-quantum computing, we're in completely different ball game. There is, again, the sizes of the signatures, for example, is too big, or the keys is too big. And it means we need to see how post-quantum cryptography will change the world around us and getting ready for this change. And it's what Google is also trying to contribute and help with. These FIPS standards, as you said, related to asymmetric crypto mostly, and on the wire, they're actually rolling out to all our customers ability and again utilization of this ML-CAM hybrid mode communication, that when you establish the session, you would be able to do it in such way that the threat of store now, decrypt later would be mitigated. And it's critically important for us. We also understand, as exactly as you said, Anand, the digital signature is the thing that keep us going, keep validating our authenticity and validating the systems, especially root of trust system, firmware, etc., that really have very long life. And that's why Google actually trying to enable in open source our very well-known libraries like Boring SSL or Tink with implementation of all of those FIPS protocols and cryptographic algorithms, ML-CAM, ISAR, ML-DSA, ISAR, and ML SLH DSA as well. And again, the problem, I think, for all of us, for all our community, to ensure that those new algorithms and the trade-offs that our customers, developers, partners need to make is well known, understood. And our cryptographers continue to do crypto analysis on upcoming algorithms as we go. So incredibly important for us to pay attention to this activity, especially as confidential computing and all encryption end-to-end is fully relying on stable and not broken cryptography. So to close our conversation with all of you, we only want to put this basic TLDR. So security and privacy is fundamental for AI future, as you've seen, and Intel's foundation technology for performant accelerated confidential AI is available today, is absolutely critical for our and everybody's usage of their systems. And we think in confidential world, in what we do for confidential AI, we still need to pay very serious attention to post-quantum cryptography in post-quantum era and preserve trust to enable our AI innovation to move forward. Without that, I think we will not have our AI innovation in the first place. All of these areas critically important, and we need absolutely your help to move these things forward. Anything else to add, Anand, before we'll close?
No, I think your summarization was spot on, and I look forward to our collaboration moving forward, Nelly. And I'll see you at Google next, for another discussion on the same topic.
Thank you so much, Anand. Looking forward to that as well, and hope all of everybody that seen this would be able to join us as well. Looking
Absolutely.
forward to that. Thank you so much.
Thank you.